Hi, my name is Andrew Morrison, and I'll be showing you how to build a monolithic concrete slab foundation. There are a lot of choices out there for foundations, from rubble trench, stem wall with footings, or slab, monolithic, or floating slab foundations. Now, concrete slab is one of the most popular sources for foundations because it encompasses the floor system and the foundation at the same time. So it's a simple one-step process rather than having to form your footings, your stem walls, and then come in and frame a floor system. It also allows for a heat sink, which is basically, if you use passive solar design, you can use the sun's heat coming in and penetrating onto the floor to heat up that concrete. And then slowly throughout the day, the concrete will release that heat back into the room. So there's a lot of different options, a lot of things to take into mind. Some things you need to consider is frost line. Some codes require that you go below frost line, and in some areas frost line can be quite deep. If that's the case, you may want to go with a basement foundation rather than a slab because you'll already be excavating so far. If you look in your codes, they'll tell you what's available for your area and what's allowed. So with all that in mind, let's go see how to do it. The first thing you want to do is called a site evaluation. Basically what that means is you want to go to the area where you're going to be constructing your slab and look at what obstacles might be in the way of that construction. Now on this site we have some elevation issues we need to deal with. This side of the slab over here is about 2 feet higher than the far corner. So when we do our excavation, we're going to make sure that we can level this out without creating any drainage issues for the slab. So on this side where we have a fairly significant cut, we'll want to slope that back, make sure we're either draining around the slab or placing some type of curtain drain in that area to handle any water that may come down. Other items that you want to look out for are trees. In this case we had a small oak tree here that we've cut out. I left it about a foot tall so I can wrap a chain and pull it out so that I get the root structure out. You can't have any roots or organic material below your slab, so you want to make sure that you pull that out ahead of time. Obstacles such as debris, if you have some heavy machinery you can move that right out of here with no problem. Another issue we have on this side is we have a structure behind here. Now there's a couple issues we need to be aware of here. One is that the gutters are currently drained down and empty out back into this area here. So that's going to be an issue of drainage that we'll have to handle either by diverting that around the structure or by creating some type of catchment system prior to where we place our new slab that can handle that water. When we look at where this slab is going to go, I know that I want to orient my long wall to the south, so I've used a compass to find south, and then I've looked at trees in the area to see how that's going to block the sun. That gives me a really specific idea of where I want to place my slab. Also, I'm taking into consideration how the placement of this slab and the structure that is built upon it is going to affect the structure behind us in terms of shading, creating cold spots, and creating little wind tunnels that just collect debris. Finally, one of the things that I do when I've got my general idea of where I want to have the layout is I get some large balloons and some string, place them in the corners that I think I'm going to want to use for the home, and put them up to the right heights for plate and then some up for the roof height. That way I can stand back at this other building and some of the other windows, look outside and see how it's going to obstruct any lines of sight. And it's a lot easier to move balloons than it is to move a concrete slab. The first thing you want to do is bring in a backhoe or a skip loader and scrape off any organic material or topsoil from the area where the slab will be poured. Topsoil and organic materials don't make a solid base for construction because they have a tendency to compact under the weight of the concrete. So whether you have to take the slab down or not, it's important that you remove this material. One thing you might want to do is stockpile the dirt off to the side because it makes for a good backfill when you're done with the construction of the building. Now with all the topsoil removed, you can start to create your actual grade for the slab. So if you've picked a low corner that you want to work back from, you want to grade all of the material out to match that corner. Again, we had some issues here with drainage from the slope coming down, so we're going to try to feather that in as we're creating the slab area. Drainage is a really important issue when you get into foundations and slabs, because if you have water draining directly under the slab, you can actually swell those soils and get some uplift and create cracking in your slab. So be sure to concentrate on that as you're creating your grade. Now we're going to actually cut this down a little bit lower than we need to go and build some areas back up with some compacted stone. So the excavator is aware of that, and we'll have to check our grades as we go along here and make sure that we're staying within our tolerances for what our final goal is. There are a number of ways to check grade. You can use a water level, you can use a carpenter's level, which is similar to a theodolite or scope with a stadia rod. In this case, we're using a laser level. I've got a receiver attached to my stadia rod that when it intercepts the signal sent out by the transmitter, beeps to let me know if I need to bring grade up or bring grade down. So I can walk to the corners and check the different grades and know where I need to go from there. Our rough grade is still a bit high, so we're going to continue working it with the skip loader until we get closer to our target. And we'll want to continue to check points in the field as we do this so we don't overcut and end up too deep on our finished grade. It's pretty much impossible to get a perfect level grade here, so we'll get as close as we can, and then we'll come in with some compacted gravel to clean up any irregularities in the grade itself. Now we've put about 3 to 4 inches of 3/4 inch minus gravel down in what's called a lift. We may want to do up to 6 inches of gravel underneath this foundation, but we don't want to put that all down at once because the compactor will not be able to get full compaction on that. We're using a plate compactor which has good compaction rates but can only compact about 3 to 4 inches at a time. So make sure however much gravel you need to put down that you do it in lifts. Now this is a pretty monotonous job to just walk in circles and compact this gravel. One way you can avoid this so you can have free hands to work on other aspects of the job is to drive a 3-foot concrete stake in the middle of the slab area and use a large diameter rope to attach to the plate compactor cage and back to the tether point of the concrete stake. By the nature of the compaction and the way the plate compactor works, it moves itself forward slowly as it compacts. So if you have it tethered to the center point, it'll actually slowly work its way around in a circle and wrap itself into the center. Then you can go back by hand and square out the corners and finish up the very center spot once you've pulled that stake. This allows you to work freely on the site on other aspects of things you might want to do rather than being stuck behind a machine the whole time. It's important to go and overlap the last area that you compacted by about 6 inches so you don't end up with areas of separated compaction. So just set the plate compactor over where you just went and then slightly onto the new gravel and you'll get good compaction. This is a pretty important spot that you want to spend some good time on. You don't want to just quickly buzz over the compaction because you'll end up with cracks in your foundation that there's nothing you can do about later. So what I do is I'll go slowly in one direction and then I'll actually turn around and come back and go the other direction or perhaps go across or diagonally to make sure that I've got it fully compacted before I prepare my pour.
Once you've established rough grade, you want to locate your corners for the building. Now one way to do this is to use what are called batter boards. The idea with a batter board is you have one on this side and one on the far side of any length of building that you want to establish. So it's basically here we've got 3-foot stakes driven into the ground and braced in both directions. We have a screw on top. We can attach a string line and pull taut to the other batter board on the far side of this wall line. We can then move this screw, or we can add additional screws and pull our string to either side to get right on exactly where we want to be in our corner. It also allows us to get perfectly square in those corners. This is going to give us an exact definition of where we're going to place our form boards. Now, we've established rough grade here, but we're still going to be off a little bit from perfect level from side to side. So what we want to do is find the high point. With the high point, we can then level out from there with our form boards, and we'll be able to fill around the outside of the form boards to hold the wet concrete in place as we pour. That's easier than digging the footings down even further into the ground. I'm using what's called a water level, and I've got some red food coloring in there that makes it really easy to see the top line of that water. Now the basis of a water level is that water will always find level in gravity. So if I am here standing at this end, I can measure down to the ground and see my distance up to the top of this red line here that's established by the water. That's 34 inches. I have a helper on the other side of this line in the far corner who's measuring the same over there. Now for example, if they come in at 34.5 inches, there's a half extra inch between the top of the red water line and the ground. That means that they are actually a little bit lower on that side because the number's bigger, so that they have further to go before they get to the ground. So we know that that end would be lower. That's the case here. Now as we go this direction, we had a different finding. We found that that end was a little bit higher, so that had a smaller number. We had 33.5 over there instead of 34. So we know that we've got some higher corners and some lower corners. Well, now that we've established the high corner, we can go from there and pull out the rest of our form boards. For a small structure like this, it's easy to do it just like that and then level them as they go.
When you're setting up the forms, you want to sight down the edge of the form to look for crown. This direction coming up or down is crown, and also some sway from side to side this way. If you have crown, you want to crown it up so that you're not creating holes in the middle of your slab. If you have some sway, you want it to sway out to the end or bow out to the outside. I'm exaggerating that in this case like this, because then we can adjust it and push it back in and stake it in place. If it's going the other way, it's much harder to pull the board back out and stake it. So you just look down the edge of it here. Now I can see that I've got some bow going out this way, and my crown is just right like that. So we'll leave it just as it is here. To attach the forms, we're using what's called a duplex nail. It's basically a nail with two heads, so we can drive it all the way down so that this head makes contact with the wood and pulls it tight, and yet it leaves us a head to pull our hammer out later and pull this back out when we want to strip the forms. Now before I get too close to nailing these two together, I want to nail this duplex in until it's just poking out of the other side. Once it's just poking out the other side, I can line these two up, hold them in place, and one solid whack will put them together. That way I'm not banging it and having things move around on me as I go. I want to be sure that the tops are lined up nice and flush, and one shot locks them together. So now I can go back and tighten this up by hammering it in later, but I just wanted to get it in. Now I can adjust everything, make sure I'm perfectly flush, which I am in this case, and I'll drive it home.
In order to square up the corner, we're going to use what's called a 3-4-5 triangle. Basically all that is I'll measure 3 feet in this direction and mark it, 4 feet in this direction and mark that, which I've done here. And then the hypotenuse of that triangle is 5 feet. So I'll measure from one side, marking it at the 5 and over. Now in this case I'm off. I've already squared some of the other corners, and so I know that there's something funky with this corner. It's not actually that the whole building is out of square. So what I'm going to do is look at my bow as we set it before. We know that the bow is going to the outside, and both of these boards are bowing pretty significantly to the outside. So what I can do is actually come in here right at my 3-foot mark, have a helper at the 4-foot mark, and just put a little bit of pressure to knee that board back in. And as we measure that, it comes out okay. So then what we want to do is brace it off in position. Now if I take a regular stake here and just brace this corner flat like this, what happens when we fill this up with concrete is I can't get my trowel in here to finish off underneath this board, and I get a sore spot in the slab itself. So I just cut some pieces of the stake and set it up on top of that. So that way, once I've got my concrete in here, I can leave this brace on and still come in with my trowel and get right under there and get a nice clean corner all the way up to the edge of the form. So what I'll do here is just tack one side in place, and then again with a helper holding one side of the tape and using their knee against the form board there, I'll hold mine end here. And we'll both we're just giving a little bit of a tweak here because we know it has to do with the bow rather than it actually being the building out of square. Now we're right on the mark there. Get my brace in place. And that's got it. Now that our corner is square, we're going to work on the level and make sure that we've got a level slab all the way across. I've got a stake here in the corner with a screw ready to go so that when I get my form right in place I can just screw it right in. Now what this is a concrete stake. This is a 3-foot concrete stake, and it has little holes drilled in it in opposing directions. Now you drive these into the ground. They're easier to drive into the ground than the wood stakes. You can really bash them into some pretty hard stuff. And with the holes already in there, you can just put a screw right in. It holds it in place. when you're ready to screw the form in place, you just go and drive it right through. So now we'll use the water level again to find out how we're doing on level from one side to the other. Now you want to establish your corner that you're working from, again the high corner, and work out from there in all directions. Don't go from one to this one and then switch and measure from this one to that one. You want to be consistent all the way around. That way if you miss by 1/8 of an inch here or there, it doesn't compound as you move through the process. Now as you can see here, I'm about a 1/2 inch low. My form board is low. The top of this water line right here where the red is topping out is the top of the form in the corner that I'm using. So what I'll do is I'll bring my form up until I meet that spot, and that's where I drive my screw. Now that, again, I want to make sure my helper's holding it right in the same place at all times, because it takes a little bit for this water level to get set up. So with her right on the spot where I want her to be, I can set mine in place. There we go, and that's got it right on. This water level is a great way to level things over pretty good distances. This right here is a 50-foot piece of line, so it really does a good job at going a full distance and getting an accurate mark of level. Running a carpenter's level on the top of this wouldn't give us a very accurate measurement.
Now that we've established the slab is level, we've come back and filled in places that were low for the subgrade. Now to do that, we've used a 3/4 inch gravel, and we've compacted it heavily in at least 2 directions. You want to try to compact it as much as you can because this is going to be where the structure rests upon. So if this isn't compacted well, you get a lot of cracking in the foundation and in the slab as well. So once we've got that in place, we're going to come in, and on top of that, we know for our sub slab, we're going to have about 3.5 or 4 inches of gravel. On top of that, we'll have 3 inches of rigid insulation. On top of that, 1 inch to 1.5 inches of sand. And finally, on top of that, 3.5 inches of concrete. So with this layout in mind, we want to come back in and fill the center of the slab area with about 3.5 to 4 inches of gravel. Different jurisdictions have different requirements for the code in terms of the size of your anchor bolts, the spacing of your anchor bolts, and the size and depth of your footing and so forth. So what we've got here is basically a generalized diagram that will give you an idea of how the slab is laid out. For the specific areas that you want to check your local code, those are identified here on the diagram. There's 2 dots at the bottom of the footing. In my area, this is a number 4 rebar, a 1/2 inch rebar, run horizontally with the joints overlapped 20 inches at least. So again, check your code, see what's required in your area, and then design to that. In this situation, we've got the rigid insulation placed underneath the slab. And this will give us a nice insulative layer between the ground and the concrete itself. There are other ways to do that, which we'll show you in the next diagram. On this diagram, you notice that we have the insulation running vertically on the exterior of the concrete. Now the major disadvantage of this is that it creates an area where you cannot inspect between the ground and the mud sill. You've got insulation running clear up from the ground, and termites and other insects have a pathway behind that insulation, potentially into your structure. The advantage of it is that it uses much less material and still creates an insulation value worth noting on the concrete slab itself. So with our 3-foot stakes on top of the screed board extending out over the top of the form so we can slide it back and forth, we now sort of saw cut the surface to move high spots down and fill in the lows. Now some lows like we had right through the middle here are not that bad. We don't have to worry about them. As I'm getting to the edge here, I can see that there's quite a bit of hole here, so if this doesn't fill it as it drops in, we'll have to put some more material in and then screed it off to the right level.
So this is really low through here.
Okay, so we have 2 low spots. Let's try that. Now around the edges, we don't have to worry too much about bringing the gravel all the way out because we're actually going to cut this out for our footing
with the square shovel once we've got this in place. So we'll have a wide footing on this building. So we won't worry about this. You want to go a little bit further than the width of your footing will actually be, so you can compact it and then cut it back out. You don't want the loose material to be sitting right at the edge of your slab. Now we've got all of our gravel screeded off to the basic height where we want it, but it still has to be compacted. So I'm going to use the plate compactor, and I'm going to do a number of passes on this. Again, we've been going in about 2 to 3 inch lifts here, so there's not a whole lot to compact, but this is the final bed before we get to the next layers of the assembly. So I'm going to go in at least 2 different directions. I'll probably go over this entire slab about 3 or 4 times to make sure that it's fully compacted. Now that all the compaction is done, I want to start cutting out my footings. This is a larger footing than normal. This is a 19.5 inch wide footing because it's for a load-bearing straw bale structure. So I come into the corner and measure out 19.5 inches, and I've placed a screw at an angle at the bottom here. And I've done the same at the other end, and for every corner I measure out that distance, 19.5 inches. I can then run string lines from one screw to the other, straightening out this end, and then I spray paint on here with some bright paint the area that I need to cut out. Then I can just go back through at this point with a gravel shovel and just cut level back from the footing all the way across. So we want to have a uniform thickness and a uniform width across this footing. So this is a great way to define that line. So using a flat blade shovel, I'll just cut out right along that line that we've marked. And I want to be sure to keep my shovel as flat as possible so that I'm coming out level from the bottom of my footing across here. So I start at the outside and create a level area, and then move over from there and follow that area over to the line. And you can see it holds up pretty well because of the compaction. It will slough off a little. It's not a big deal at this point. It's the difference between compacted rock and concrete. So you want to be sure to have a footing that's wide enough, and at the same time, you don't want to worry about this stuff that falls in. We're going to run the compactor through here one more time to compact the bottom of this footing before we're all done. After we've cut out our footing, we want to go back with a hand tamper and compact any loose gravel that's come up in the bottom of the footing. Now, whether you're using the hand tamper or the plate compactor or really any kind of compactor, it's important to have the material that you're working just slightly damp. You don't want it to be wet, but you don't want it to be dry. With a little bit of moisture in there, it really helps the compaction. Otherwise, when it's dry, it just wants to separate, and when it's wet, it just creates all kinds of a squishy mess. So again, you want to just have things just lightly dampened. Now I'll walk down the whole footing here with the tamper, flattening it out as much as I can and just putting that last oomph on it before we go and get ready to set up for the pour. Now I don't want to hit too close to where I've cut this wall out along the orange line because it'll actually dislocate more than I'll compact. In order to ensure that our form boards are straight, I'm pulling a string line from one end to the other. The way I set this up is a screw back on the form board, pull your string across a wood block. If you have plywood, that works the best. Wood has a tendency to split out, but this is what we had on site. And then I have a second block at the other end and a third block in my hand. This third block I can use to slide and check the space between the form board and the string line, because I know it should be equidistant to this thickness right here because it's the same piece of wood. You want to secure the form in place about every 3 feet down the length of the form. And in order to check whether it is too far in or too far out, you run against the string line here with your block of wood. If the form boards are too far out, you'll come up to the string line and you won't be able to get the piece of wood between the string line and the form. So you know that you've got to actually push your form boards back in and brace them in position with an angle brace. Now, the opposite to that is you come up to the string and there's a large gap or even a small gap between the string and the piece of block wood. Now in that case, you need to pull your form back out. Same thing, you want to anchor it in place once it's pulled out into position. In that case, you may have to do a vertical stake and a horizontal and a diagonal stake in order to firm it up in position. Now I've gone ahead and braced this off every 3 feet all the way down the form board. And right now where it's at, it's just perfectly sliding right past that string. So I can secure this in place now. Again, I took most of the bow that was in this board, came out when I was around the middle area here. That's where the most flexibility in the board is. And that's all set. With the form board straightened now, I've come in and put a plaster relief on the inside here. What this is, again, we're doing a straw bale wall here, and we have 1.5 inches of plaster on the outside of the wall. So what I want to have is a detail in the foundation where the concrete comes down, moves out, and goes down to the outside so that my plaster can then come right down and line up close to flush with the outside of the concrete. So here I've used a 2x2, screwed it into place about every 2 feet at the top edge of the form. And then I put a little piece of electrical tape on here just to keep the concrete out of the threads of the screw so I can actually get this thing off when I want to take the form out, and I can reuse these again at a later date. Now if you have plumbing or electrical that you're wanting to bring into the building, you'll need to cut some trenches down below grade here. You need to check with your local code to find out what the depth of the trench needs to be for electrical and plumbing lines, and then come back into your building and run to wherever you need to go with those lines. Now it's important that you straighten your form boards first so that if you're targeting an interior wall to bring your plumbing line up in, for example, that you're coming from a square line off and measuring in the right direction. If you measure that distance and bring your lines in before you straighten your forms, when you actually build the house, you could be off with where that wall is placed. On top of your gravel, you want to lay a moisture barrier which will stop water from wicking up through the insulation and then ultimately into the concrete and up into the house. So we use a 6mm plastic. Careful when you step on this stuff, it's really slippery. We just spread this out over the slab. Like that. Now if you have any joints, if you're doing a larger structure and you have joints where the plastic is lining up with another piece of plastic, you can use a water-resistant tape like a duct tape or some type of water-resistant tape to tape those joints so you don't end up with moisture being able to get through those cracks and up into the slab foundation. Now on top of the plastic, I've placed 3 inches of rigid foam insulation. It's important to use the extruded polystyrene insulation, which is rated for structural insulation. It can be placed underneath the slab. There are other types of foam that are designed for vertical installations along footings and edge walls, but they're not designed to hold the weight of the concrete on top of them. And once I've installed those at 3 inches, I'll have an R15 value underneath my slab. I've taped the joints with same tape as I talked about underneath on the plastic. We're using a water-resistant duct tape, and that keeps this joint fully sealed. And this will, not only with the plastic below, but with this insulation in the tape, will really eliminate any moisture from moving up through the slab. I've got sand on top of the insulation, and the major reason for this is it allows the concrete to cure at equal rates in both directions. Above the concrete, there's not a whole lot from stopping that moisture from coming out. And what will happen if we have something that's water resistant right underneath the slab is it'll want to hold that moisture and it'll wick all the way through the concrete and dry unevenly. So this way the moisture can sink down into the sand and stay as a wet base and keep a slow cure for the concrete. I've gone ahead and used a screed board to get it level, which is its second purpose, is it becomes a leveling bed. Now I know I want 3.5 inches of concrete, so I used a 2x4 here and just ran it as a screed board down the sides and got it completely flat and leveled off. In order to eliminate cracking in your slab, you want to put some kind of structural steel. Concrete has a great strength in the compressive direction, but in tensile strength it's very weak, so we use the steel to supplement the tensile strength of the slab. Now I'm using a welded wire mesh here as my structural steel. You can also use rebar. In this case, this is something you can use where you don't need any specialty tools. You just need some wire cutters and some gloves, basically. Now I'm using what's called adobe right here. This is a small little block of concrete that has wire twisted coming out of it. And what you do is you attach the wire right to it, twist it down, and make sure these go down like that. What it does is that keeps the wire up off of the sand. as you pour the slab, if the mesh is right down on the sand, it's not actually getting in between the concrete and you're not getting any extra tensile strength out of it. So this way it keeps it up off of the sand, keeps it embedded in the concrete. Now this wire has a tendency to roll and to bend up and kind of be hard to work with. So one of the other advantages of the dobies is you can hang them in places like out here off the edge. We can hang one in the air, and as we pour the concrete, it'll really pull that down and keep it down in the slab and stop it from peeling back up and coming out of the top of the slab. Whether you use the welded wire mesh or rebar, you need to be sure to keep it away from the edge of the form boards. Now local codes will have certain restrictions about how close to the edge of concrete you're allowed to get with your steel. I like to keep mine about 6 inches in from the form board. The reasoning behind this is if it gets closer or actually touches the outside of the form board, then you're going to get moisture affecting it and rusting it out, and then it'll start to travel down the steel and decay all of the steel down that run. So if you keep a good 6 inches around the outside of your forms, between the inside of your forms and the outside of your wire, that's a good safe distance. Now you'll have a number of courses of this wire mesh that you put down, and when you go from one course to the next, you have to overlap them so that they become one solid unit of steel. So in this case, I've just temporarily lashed them together with the wire from the dobie, and that gives me my nice overlap here, and I can keep moving down. Then when I come back, I'm going to want to add more dobies in places that are low, and on all my overlaps, I'll come back and tie every joint together so it makes one uniform piece of steel within the slab. So most code districts require that you have rebar in the foundations and some type of either rebar grid or welded wire mesh within the slab itself. So when you're working with rebar, you're going to need to have a rebar cutter bender. You can get these at any local rental yard. This is basically what it looks like. We'll place the rebar for bending on the wheel and underneath this, or I'm sorry, above this cuff. It can be pretty rough with rebars to where you need to measure it. I'm going to be pretty close here. And right about there. And the measured area goes right underneath in the middle there, because that's where the bend is going to take place. Once it's in place, you grab the pole, just lever it right back. There's your bent piece of rebar. So when we measure for our next piece of rebar, we need to be aware that we'll have to have a lap from the end of our last piece back over with our new piece so we can tie these two together. I'm using about a 2-foot lap here. As we come out along, we can measure down to the other side where we need to place our bend. In this situation, it's 115 inches. Now I'll need to remember to add 2 feet onto that after the bend to connect it to this other piece of rebar that we already have in place. So for marking the rebar when you're measuring lengths, it's good to have a lumber crayon or something that's got a little more meat to it. You're not going to be able to mark on the rebar with a pencil. So this shows up pretty well. It gives you a pretty accurate measurement. So now I've placed the rebar inside the center loop here of the rebar cutter. The cutting apparatus is right about in the middle here. It's the same mechanics as bending it, it just is a different hole. As we pull it back down, it takes a little muscle, it's going to snap it off. And there you are, cut to length. Now these ends are going to be sharp. It's one of the reasons I'm wearing gloves. Not only is it usually covered with some kind of oil, but these ends that you cut will be very sharp, so be careful. So for attaching the loose ends of the rebar together, they make a wire with knotted ends and a puller. And this puller swivels out as it pulls and it twists the wires together. So you take the wire, bend it underneath the rebar, place your hooks and pull, and you're attached. So I've gone ahead and made a grid of rebar here on top of the slab, and basically we've got an 18-inch center, so 18 inches in each direction is the measurement for this grid. I use the same method of attachment using those twisters to attach about every other space. I don't attach every one, it's a solid grid in and of itself, just with every other space tied together. I then took one of my bends that runs through the foundation and lifted it up, hanging it from the ends of the grid so that it's elevated and hanging within the concrete.
when we pour this, I'll either have to place what are called dobies, which are small little pieces of rock which lift the rebar off of the sand, or I'll have to lift it by hand with a rake as the concrete is poured. The rebar needs to be not below the concrete, but within the concrete. So we want to put it right about in the middle. If we've got a 4-inch slab, about 2 inches off the ground, which is what a dobie would give us. Same as the grid pattern in the foundation wall itself, we want to make sure that the rebar is floating within the concrete. As I said earlier, this one here is hanging, secured from the grid, which keeps it up into the concrete. The bottom one, which we want to keep close to the bottom of the foundation, is about 1.5 inches, 2 inches perhaps off the ground, and that's about where you want it to be. Now, before you pour the concrete, you want to make sure, and throughout the process, you want to make sure that there's no organic materials, no sticks, paper, any of that kind of stuff in the slab. Rocks, nails, anything like that is fine, but anything that's organic will decay over time and create voids in the concrete.
With all my dobies in place now, I've gone and laid out and installed my anchor bolts. Now, the actual layout for anchor bolts will depend on your code, so check your local code book and see what's required in your area. Now, when you lay them out, you have to keep in mind where your openings, like doors, will be, and also where the actual plates themselves run. So I start in one corner and I work down laying out my plates. I know I have a 10-foot plate, then an 8-foot plate, and a 12-foot plate. So I have all of those marked on the actual form boards. The reason I do this is that in my code, and most likely in your jurisdiction as well, you have to have an anchor bolt within 1 foot of the end of your board. So you have to mark those all out. Then you can start with your end pieces and then find the centers based on what the local distance between bolts is in your area. Now, I'm using here what's called an anchor mate. There's a number of different ways to do this. You could do it just with some scrap wood. I like the anchor mate because it's designed specifically to give me a certain offset and hang my bolt at a certain height. So the idea here is I set this right in place, and now I don't have to hand place any of the bolts around the building. Again, this is a load-bearing straw bale. I'm going to have another plate on the inside, which I'll have to hand place those bolts. So this just eliminates half the work for me before the pour begins. Now, I've got this wall braced off pretty significantly. It's a little bit of a drop here, so to get a stake deep enough into the ground, I wanted to make sure that I had enough of these so that the wall didn't bow out with the weight of the concrete. Another thing I've done is I've left a dry line or a string line on here so I can come back with my block of wood like we did to set this in place and check it as the pour takes place. So if we do have an instance where one of these fails or gives way a little bit and we get a little bow in the wall, we can check it and move it back into place and re-brace it at the time when we're pouring. So it's just another way to be able to check the wall and make sure we end up with a straight wall. I'm using another concrete cutout here. Basically what this is a 1-inch nominal thickness piece of wood, plywood, that is cantilevered out over the slab. Now what happens here is the concrete will fill up underneath this and around it, and when the concrete cures, this will end up being a notch out that's the exact width of the door threshold. So when we trim this out and bring plaster to it, this is a really nice detail which allows us to, once the concrete is cured, be able to sweep stuff right out of the house without having to deal with the threshold. Now, this is roughly what your subgrade will look like before you get ready to pour. We've got our, again, our compacted gravel, the gravel bed raised up, the visqueen, which is the waterproof plastic, the foam insulation, the sand, the dobies holding the steel up off of the sand. So this is basically a complete ready to go slab. I've got some areas where I've bent the wire down to support it and keep it up in the air like this when the concrete lands on it. Other areas where the dobies are actually hanging to stop the wire from lifting up because its natural bend wants to pull it up. So with a hanging dobie, we can pour concrete on top of that and it'll pull the wire down. Also here in the corner, I've got my conduit for my electrical that's come running up through here. Now, I just stubbed it out outside of the building. I didn't want to trench the full distance right now. So I've marked it with a stake. It goes right down to the pipe itself, so I can then trench back this direction and find it without destroying my stake in the process. You want to order your concrete about 2 days in advance. That way you can be sure that a truck will be available when you're ready to do your pour.
When you call the yard, they'll want to know how much concrete you want to order, what strength, the aggregate size, type of Portland cement, and what, if any, admixtures you want placed into the mix. Some of this information is basically standardized, whether you're doing flat work or doing structural foundation walls. Now we'll lay out some of the details of how to address which admixtures, if any, you want to put in, which aggregate size to pick, and strengths. We'll also lay out how to calculate how much concrete you want in the following chapters. We use basic math to come up with the calculations for estimating your concrete. If you take the length and width and thickness of a slab, for example, in feet, and multiply that out, that'll give you the amount of concrete in cubic feet. You can then translate that into cubic yards by multiplying it by 0.037. As you can see in the example here, an 8-foot by 10-foot slab, 3.5 inches thick, would equal 23.2 cubic feet, or 0.86 cubic yards of concrete. And with a monolithic slab, you want to calculate the slab separately from the footings. That way you can do a basic math calculation on the width and depth of the footings and a calculation on the slab itself. Add the two together and that'll give you your calculation for the amount of concrete you need. Now in general, it's a good idea to add about 10% for waste or for slight variations in the calculations. If you have a perfect rectangle footing to work with, then that might not be necessary, but out in the field it's rare that you get a perfectly cut footing, so it's a good idea to add a little bit of waste in there to make sure you have enough concrete on the day of the pour. When you're deciding what strength concrete to use, you want to look into your local code book. In general, a 2,500 pounds per square inch mix will be strong enough for any code. When you're deciding what aggregate size to use, if you're doing simple flat work like a sidewalk, a 1/4 inch gravel and sand is a good mix to use because it's a little more workable. When you're doing a structural monolithic slab like we have in this case, we're using a 3/4 inch gravel and sand as the aggregate types. That gives it a little more structural strength, but it's still workable. Admixtures such as accelerators, retarders, water reducers, and air entrapment can be added to the mix to help with specialized conditions you may be working with. Accelerators speed up the curing time, retarders slow down the curing time. Water reducers make mud more plastic so you can actually move it further without losing the strength of the mix. And air entrapment does exactly that. It holds millions of little bubbles in the concrete. And what that does is it allows the freeze-thaw cycles to be less impactful on the concrete. There are 5 different types of Portland cement you can use in your mix. General purpose, type 1, is about the most common that you can use, especially in residential projects. And if you don't specify anything other than this is what you'll get in your mix. Type 2 is a reduced heat production, which means that it doesn't produce as much heat as it's curing, so it's good if you have a larger job, gives you more time to work the concrete. High early is the opposite of that. It sets up rapidly, and that's used when you have to put bearing on the concrete soon after the concrete will have cured. Minimal heat production produces even less heat than the reduced heat production in type 2. So type 4 is used in really large-scale projects like dams and things like that, where you have to have a long time of workability. And finally, type 5, sulfate resistant, is used in areas where your soil or groundwater has high alkalinity.
With concrete, you want to make sure to keep your tools wet. That'll help to keep the concrete from sticking to them. So whenever you're waiting for the concrete to show up, or when it's here, or certainly as soon as you're done using the tool, just get your tools nice and wet, and it'll keep the concrete from sticking. You want to make sure that the inside of your form boards, your anchor bolts, the whole slab is nice and moist. And do this on the outside as well. And on the outside here, it's just stopping the concrete from sticking to things that you don't want it to stick to, or at least lessening the chance of that happening. On the inside, it serves the same purpose with the inside of the form boards to release them easily, but it also is putting enough moisture content down in the slab itself, without getting it wet, of course, that enables the concrete to cure slowly. If all this sand is dry underneath, it's going to really quickly suck all the moisture out of the concrete and make for a poor curing of the concrete.
You want to be absolutely sure to be ready when the concrete truck shows up, because they won't want to hang around waiting for you. One question they may ask you is how wet you want your concrete, and that'll depend on how quickly you want it to cure. Now on this project, we don't have a whole lot of time before the sun goes down, so I've asked him to keep the mix pretty dry. The drier it is, the harder it is to move around the slab, So if you have the ability to keep it as a wet pour, it's a good idea to pour it as wet as the truck will allow you to do it, and then you'll have a lot of time to work with it, and you'll be able to move it around a lot more easily. Another thing you may notice is that he's dumping the concrete pretty much right in the middle of the foundation slab forms here. Because of the terrain, we weren't able to get the truck right up onto the forms. Now, if you can avoid this, do so at any cost, because what it means is I'm going to have to move this concrete to all the corners of the slab without the help of the chute. Not only is this laborious and tiring, but if I'm not careful, I get some separation between the aggregate or the larger pieces of gravel in the concrete and the rest of the mix. Now, if I get separation, that's going to create a problem of uneven curing throughout the rest of the process. Once you've got the form boards pretty much filled with concrete, you want to run a screed board across the top. And you can see we've left a little bit of room down at the end here where we're sliding towards, so that any excess concrete will fill that void. If you put too much concrete in at once and then try to screed it out, it just becomes really tiring, and it's hard to move the concrete along, especially with a dry mix like we've used on this project. And we're using a magnesium screed board. You can also just use a 2x4 or 2x6. Any of those will work. The magnesium is a little easier to use because it's a bit stiffer than the wood, and it cleans up really nicely. It's also much lighter than using a 2x6, so the weight of the concrete is enough. You don't have to have the weight of the screed board itself as well.
Now once you've screeded everything, you can make sure that your corners are square and put your brace back on in place if you need to. Now with all the bracing we've got here and the corners marked off, your corners may have stayed square during that pour with no problem, in which case you can take the braces off to trowel out and then replace them when you're done. So basically what we've done is we got the screed board down through here, but we can't get all the way down to the end because of our anchor bolts. So I'm just using a bull float, a magnesium float, excuse me, not a bull float, a magnesium float to just level it out, get this basically backed in, and I'm using this area back in behind it as a screed in the other direction. So we're still using the screed process, but a little bit different on a smaller scale here. Get into the corner. And again, now here you can see where the raising of this brace really comes into play now, because I can get my trowel right under here and get under by these bolts. If I had the brace down on the concrete, same level, I wouldn't be able to get in there and clean that up. Okay, now you don't have to do a thoroughly impressive job here. All you need to do is get it basically knocked down. We're going to come back in now with either a jitterbug or a roller bug tamper and tamp it down. Now that takes some of the larger aggregate and kind of sinks it down in, and it brings the cream up to the top. So it not only compacts it, but it also brings out a more workable material to the surface. Now we've got a pretty strong sun here, so I'm going to just mist the concrete down as we go in between each stage here so it doesn't fire off too fast, and just finish cleaning off my tools. With the jitterbug tamper, you want to just get right on into the concrete and step in here. You step out away from the foundation edge, because that's where you've got a lot of concrete and you'll likely sink pretty quickly. Now I'm just lightly tapping the surface with this and bringing up what I call the cream, and overlapping it and working it into the corners. This is also, look at your footprints. You know when you've got the cream up to the top, when your footprints have filled back in nicely. So the game of concrete is definitely pretty much a race against the clock. So you want to move as quickly as you can so that things don't set up too fast on you. Because once they're set up, there's not much you can do about it. So using the bull float, I'm using pretty even pressure all the way across. And this takes a little bit to get used to, of the angle that you want to push that float at. But you're just working it back and forth, leveling out any high spots and low spots. You can see in here we've got some low areas. So right now I'm just going to go back and forth and let them fill themselves in as I pull. I'm also, at this point, I'm going in the same direction that I did the tamping, so that the width of my bull float can span across the lines that were made by the edges of the tamper, because sometimes they create channels. So this way it stops it from becoming a channel. And then I'll turn, and once I get most of the way across here, turn and come at it perpendicular to this direction to even out any lumps that are going the other way. So now moving in the opposite direction from where I was just troweling, I come back across the same area. Now that area is low. So what I had done when we were screening, when we got to the end of the foundation, we had too much concrete. I made a pile of it so that it's still clean, and I can get this in here and fill this hole. I'll give it, that's probably enough to get both of those. And then I'll tamper this down again. Now I waited until this point because I can reach it from the edge. If this is a bigger slab and you can't reach a spot that you suspect is going to be low, you might want to fill it and tamp it before you start floating it all the way out. Leave yourself a way to walk in there without damaging work that you just did. So I'm still low in that spot, so I'll work a little more mud into there. This is a great way to get a very even finished slab. Now this slab is going to be a finished interior slab, so this is the finished floor in the building we're working on. So we're putting a lot of extra attention into filling these little surface imperfections. If you're doing a slab that's going to be underneath carpeting or floor, or it's going to be a garage, you can probably work with this a little bit less on the perfectionist side and not worry about surface imperfections too much. So now I'm just continuing around the surface of the slab and working the cream a little bit. I want to be careful not to overwork it, but at the same time, I want to be sure my level is as smooth as I can make it. So here around the edges, I'm using my magnesium float, and I'm coming off of the form boards as my screed to get my general elevation, and then I can just use it to clean up like this. Now it's really good to get underneath these anchor bolt anchors or any other obstacles that you have in the way, because your plate needs to sit down on top of these, and if you've got a bunch of concrete popping up here, it's going to make it really difficult to get your plate to sit down flat. So a little attention around those edges is a good idea. And this is starting to set up pretty well now. So when I've got some spots where I need a little extra mud, I can put quite a bit of pressure here. Make sure I get everything in place. Now right here we've got a small hole in our concrete, and we're already pretty set up. So again, I'm going back to my pile of clean concrete that I left over. I'm going to tamp this in here, just sort of connect it, mix it up with the concrete underneath it. I don't want it to just be a surface patch, because then it won't adhere and bond well. So now that I got it in there, I can really jam it up, put some pressure on it. And just with this float, I can actually bring a lot of cream to the top. I don't have to retamp this whole thing out. This is just a good way to fill in low spots. Again, the more even you can get the perimeter especially, and if you're doing a finished slab, the interior as well. But the more even you get this, the easier it's going to be to work your frame up from here. Now I'm just going down the sides, basically vibrating the concrete down so I don't get a honeycomb look, which is, basically if you flatten that down, you can see the gravels and some cavities where the gravel was, and voids and bumps, and it's just an ugly finish. So here, by just vibrating it out like this, the concrete will settle down and smooth out enough to where we get a nice clean finish when we remove the form boards. The final step is to use a steel trowel.
Now it's important to know exactly when the slab is ready for you to get on it in terms of troweling it out. If you get on too early, it'll squish all over the place. If you come too late, then you can miss it and it'll be too hard to work. So you just want to keep an eye on it. It's going to vary on your weather. If you're in direct sun, if you're in shade, what the temperature is, the moisture content of the air, all those things have an effect. So you just want to keep track of it. When you get it to where it's really hard, you can put a lot of pressure on it and it just barely cleans up the surface, you're ready to get on. Now I start in the middle and work my way back out so I can do the final finish from solid ground. In order to get out to the middle, I'm using knee boards. It's called an easy kneeler. You can use just a regular piece of plywood with a handle screwed on from the underside so you can move it around. The idea is to set these out here far enough that you can reach out to the middle, and because they're wider, they're not really taking the weight of your body on your knees. You're taking it spread out over the larger surface area so it doesn't leave a dent. Now when you get out to finish it, just using a regular steel trowel, you want to keep an angle on it and push down on the back side. So whichever direction you're moving, you're pushing down on the back side of the trowel. You just want to go back and forth and start out with some harder strokes where you're really putting some muscle into it, and that'll help you smooth out any irregularities. And then as you work it in more and more, you can become more and more gentle on the actual trowel itself, and you'll find that the cream will start to work back in to the slab nicely. You want to overlap from where you last were and leave space to overlap in the other direction. Now depending on how smooth you want your finish, that's going to depend on the number of times you go over this. You know, do the whole slab and then come back and do the slab again. You can really polish it out. And then to move back, I just step onto my rear knee board here, move this one behind me. I can use my trowel to lean on. Then I got my feet on there. It keeps my feet. Otherwise, if I just use one, I have a tendency to want to put my feet down, and I can't reach out as far onto the slab because I've only got one to work with. This takes a little practice to get the right angle and the right touch so you're not gouging holes and you're not leaving marks that look worse than when you started. So don't get discouraged. I need one more board here. Now, you don't have to finish a concrete floor this way. This is going for a pretty nice shine. There are much simpler ways of doing it. You can use just a broom and drag a broom across it. They actually make broom extensions for the same extension pole I was doing with the bull float. You can get longer extension poles and put them together and brush this entire thing in one direction. There's lots of different finishes you can do. This is going for more of a polished look, and we're going to come back and do some acid stain on this, so we want it to be a nice finished floor. Now this process takes quite a while, so you definitely want to be prepared to spend some time with your slab. It's not just the pour that takes time, the actual finishing can take a long time, and there's a lot of time sometimes in between it, where if it's taking a long time to cure, to set up where you can actually get to this point if it's in the shade and it's cool and moist outside. So definitely plan enough time for that. After your concrete is finished, you need to let it cure properly. In order to do that, you want to keep it wet for at least the first 7 days. A proper curing takes about 21 days, and the first 7 are the most crucial. In that time, you achieve most of your strength, And if you do not cure it properly in this time, you'll get cracking in the surface of the slab and other structural defects. The best way to do this is to keep water on top of the slab at all times. If you can find a way to build up and hold a pond of water on top of the concrete, that's fantastic. Concrete will cure properly underneath water as long as it is placed properly in the first place. Another way to do it is to lay burlap or straw down and get that wet. That will hold additional moisture. Then you can lay plastic on top of that, which will keep the moisture in. Anytime you can shade the slab from direct sun is a good opportunity as well. If the temperature is going to drop below 40 degrees, you need to do some sort of thermal insulation. Again, the use of straw with plastic on top is a good way to achieve this. If you're going to be doing more than one slab and you anticipate having temperatures below 40 degrees more than once, then you might want to invest in thermal blankets. These are actually designed specifically to keep the heat in as the concrete cures. In terms of keeping the heat in, the concrete will produce its own heat as it's curing through the chemical process of hydration.
It's been about 3 weeks since we poured the slab, and now that's enough time for the concrete to cure properly. So now we're ready to go around and pull off the anchor mates and take off the forms. Now when we pull the form boards off, you just give them a little whack just to loosen them up in case they're still tight against the concrete. The concrete will have shrunk just a little bit in its curing process, so it's probably pulled away from the form boards in most places. And we'll pull our duplex. Now again, this is where the advantage of these nails comes in. Because of the two separate heads, we can drive the first one flush and then use the second one to pull it back out. So this is where it becomes a real advantage over just using a regular nail. So we've got it loosened up here in the corner, so we should be able to just kind of pop it off. So you can see the plaster lip we've got here. This is going to give not just an overlap to stop the wind-driven rains from getting in, but it'll also create a bearing for the plaster, which in this structure we're going to use as a structural plaster skin. This project is relatively small at about 200 square feet, and yet it still took us about a month to complete. We had the first day was spent with the backhoe clearing the site and creating the actual pad for the construction. The second day was setting batter boards, pulling string lines, and setting our form boards. The third and fourth day were full of putting the gravel and compacting the gravel inside the slab, cutting our trenches, bringing in conduit for electrical and or plumbing, setting anchor bolts, rebar, wire mesh, all of the items that need to take place before the pour. And the fifth day was the actual concrete pour itself. Now it's best to do that pour earlier in the morning so you have the full day to work on finishing the slab. Otherwise you may end up staying up late at night doing your final polish. On a larger foundation where you have more mass of concrete behind the walls, you want to make sure to really brace it off well. You can see here we've got not just angle braces, but actual solid braces coming out to stakes that are back down into the ground here. These are really holding these firm and then nailed on to the form boards there, as well as the vertical stakes as well to hold it in place. Now once you have all your stakes in place, you want to put some plastic caps on top of them so that if you fall, you don't accidentally impale yourself on one of the stakes. One of the most difficult things about large slabs is having to place anchor bolts in the middle of the field. With nothing to support them on, it's hard to get them to stay in place while you do the pour. One way to fix this problem is to drive a piece of rebar down into the ground and then attach the anchor bolt to that piece of rebar. Now the key is that you cannot have the anchor bolt touching the metal of the rebar, because the rebar will eventually rust out and that rust will travel up and ruin the bolt in terms of its anchoring to the concrete. So we isolate it here by wrapping it in some foam and duct tape, and then duct tape the bolt to the piece of rebar that's already been wrapped. And this way, with all of our bolts in place ahead of time, we can bring a concrete pumper in and use the hose to place the concrete in the footings while we can still walk around the rest of the slab. So here we can just use the hose to put the concrete exactly where we want it. On this slab, we went ahead and did the footers first rather than doing it as a monopour, because we did have so many bolts. We wanted to be able to be sure that we could walk around and adjust those bolts to plumb if they were to get knocked out while we were pouring. So this way we can go around, pump the footings full of mud,
check our bolts, let it set up, and then come back and work on the slab at a later date. So you can see here, the proper way to hold this hose is a little bit further back than right up front. If you hold it right up front, it's going to jerk you around quite a bit. So if you can hold it back a little ways, you'll get a better grip on it, and you'll actually have more control of it. And by holding it this way, you can place the mud right next to you, or you can actually project the mud quite a distance away from you. Now you don't want to shoot it too far, because when it hits the ground, you might get separation between the aggregates and the fines and the water and all of that, and that will actually weaken the concrete. But you can see here is a great shot of the concrete being projected out. It hasn't quite hit the ground yet out by that second footing there. But this is just a great way to place concrete across a large slab where you don't have to be hauling wheelbarrows back and forth, which is otherwise what you'd be left doing. And you can see here now the footings are all poured and we're ready for concrete to come in to do our finished slab. We'll still have to put our field rebar in place before we do that. If you have a larger slab, it may not be possible to do the screeding in one pass, in which case you can break out the slab into sections and put temporary screed posts in place. Now, a screed post is basically a concrete stake driven into the ground or set on a pedestal, which then has a screed hook coming off of it. The hook can be adjusted vertically up and down on the stake to adjust for the correct level. You then put a 2x4 or a pipe or whatever you want to use as a side screed level, and you run your screed board back and forth as we showed you earlier in the screeding of the concrete. This way you can then pull the screed board off, pull the screed hook and the screed post all out of the concrete, and then set up another section to do once you've completed each section. It allows you to move with smaller areas at a time and not try to move so much concrete and flatten it out at once. So this is a perfect example of that. You can see we've got this set up into a number of different shutoffs where we can pour just a little bit at a time. So now again, we're using the concrete pumper to place the concrete in position. You can see we've got, running from left to right here, we've got some removable screed boards that are on our screed posts, and then to the far left of the picture we have a shutoff, which means that we've got a board that will stay permanently for the duration of this pour, so that we don't run into the next area of our pour. We don't want to try to cover too much at once, because with weather conditions and so forth, it'll be hard to finish the concrete in a way that will actually do a good quality finish. So we pour just enough that we can handle in a day. You want to make sure to get it all in place underneath our removable screed boards here, so we don't have any gaps. Again, just continuing to pump all the way across. Now, as you get better with the screed, you'll find that you won't have to actually hang the screed board on top of your guides. You'll be able to use just a straight 2x4 or another type of screed to just pull right across the surface. Now, this takes a lot of skill and a lot of practice, so it's not something I recommend on your first slab through. But once you get this, it actually makes it a lot easier to use a mag float around the edges to create a level surface coming off of your form, and then just use a straight 2x4 to screed from there. When you get the skill, it makes it a lot easier. And you can also use a smaller section of 2x4 to just level out some places that you don't need to run the entire screed board over. And when you're ready, when you've got your section in place, you can pull out your temporary screed board and just set it to the side. This is where these screed posts come in really handy to do a multiple stage pour like this. So with that set to the side, we can level out areas where we have a little bit of imperfection, and then come back and use that surface now as the screed for that side of the pour. So then when we pull the stakes out that the screed posts were sitting on, we can then clean up that entire line and create something that we can actually use, like I said before, as our screed. So again, we'll run a mag trowel up and down on this and flatten it out and get this as level as possible, because this will be where we set our screed board as we move back towards the right of the frame. We'll use that screed board to run right on top of that concrete surface, and on the form board, if you're just getting used to this, you're going to want to run it against the form board. Again, once you get a little more skill, you won't have to run it on the form board. You'll actually rather use the mag trowel to flatten out along the form board, and then set your screed run on top of that. It actually gives you a little more maneuverability. You don't have to worry about hitting the stakes and so forth. It just makes it a simpler process all around. Another great advantage of a larger slab is you can run what's called a power trowler on top of it. Now you have to wait a little longer because, as you can see, you're actually walking around on the surface of the slab, so you're not using your knee boards in this situation. Basically what you do here is you'd either run your knee boards while you're doing your first first pass with the troweling, or you could use a trowel out on an extension handle. And then once the concrete's set up a little bit more, you can get out there with this machine and cover a lot more ground a lot faster with a lot less labor. So it just makes it, again, it's an easier process. It's where the mechanics of a tool take away some of the labor of it, and it gives you a nice, really smooth troweled finish. Now you want to be careful if you're going to be doing any type of stained finish after this is all over. If you trowel too heavily with the power trowel, you'll actually seal the surface of the concrete so tightly and create such a sheen that the acid stain will not be able to penetrate deeply into the concrete and you'll get a weak stain. So it's an area where you need to be planning ahead for what you're doing next. But if you're going for a smooth, high sheen surface, this is a really easy way to get it done. Concrete stakes are a really good way to secure form boards, but they are very expensive. So you want to be able to use them again and again. And one thing that can be frustrating is when we do a pour, concrete will often slip out from underneath the form boards, as you can see here in the middle of the picture. Now we've also used some oriented strand board, or OSB, below our form boards to actually try to stop some of that from coming out, rather than piling dirt up against it, because that makes it harder to pull our stakes out when we're all done. And what we've realized over the years is that if we wrap a little pipe insulation, plumbing pipe insulation, around each of our concrete stakes, when the concrete does squish out from the holes that it will inevitably find, it wraps itself around the insulation and not around the concrete stake. So when we're ready to strip our forms, we can pull our concrete stakes straight out and they don't have any concrete holding them in place at all. It's a cheap and easy fix to a very frustrating problem. And the insulation itself, it doesn't matter if it gets left in the ground. Eventually it will decay, but it won't have any bearing on the structural integrity of the building. And curved walls are a nice feature in any home, and they're actually quite simple to do with concrete. It may seem difficult from the outset, but it's actually quite simple. Basically what you want to do is do a lot of extra staking along the curved section to hold the bend of the boards in place. Not so much for the weight of the concrete, but just simply to hold the shape of the boards. So we use a lot of vertical stakes and also angled stakes along that curve to hold it in place. You can see here all the angled stakes that we've got in here and the verticals that are holding this OSB form in place. Now it's difficult to get a thick enough piece of OSB to bend because you have to have it thick enough to hold the weight of the concrete without bowing out in between the stakes. So what we do is we use one sheet of 1/4 inch and we create our shape, and then we come back and screw another sheet onto that, giving us a 1/2 inch full thickness. But it's too difficult to bend a 1/2 inch piece, so we use the 2 1/4 inch in its place. Finally, you'll have to run the rebar in this curved section. Now you could use the rebar bender to do this and to curve it as nicely as possible, but it's really not that important. As long as you have the rebar basically in the shape that you want, that's all that matters. So we actually come in here with a straight piece and just bend it against our knee as we move around that curve, which gives us close enough. It's never going to be seen. As long as we keep it away from the edge, it'll be structurally sound. So we've got the rebar in place here for the footings, and you can see we've got 2 bars running in the bottom of the footing and 2 bars suspended above for the top of the footing. Now we've lapped these a good 24 inches and tied them off with the twisty ties, and we've got just a temporary piece of rebar across the top here that's holding these top pieces in place. Now when the electrical comes in, we need to know if we're going to have a service panel on the building. In this case, we have an electrical panel that'll be on this north-facing wall. And so in an area somewhere close to where that panel might go, we're going to have what's called a U for ground. This is basically a long piece of rebar. It's run down into the foundation and extends out. Oh, it's about a 20-foot piece all told. Now this piece is required to ground the electrical panel into the slab itself. So this needs to be in place before we pour our slab. We've also run a piece of conduit here that will run out as a home run to the electrical panel down in the slab. And we can also go up the wall and out into
the roof line, but there's some places where it's actually going to be easier to run a conduit down through the bottom of the slab. Now this doesn't have to end up buried too deeply in the slab, it just needs to go down and be out of the way of the insulation and other materials so that we can keep our insulation flat before we do our pour. Now you need to check with your local power company. Most companies don't want more than about 270 degrees of turns from where the power comes from its source into the building. So here we've got our 90-degree sweep coming up right to our panel location, and we've got a pull string in there, and like I say, we've been sure to set it up so that we don't have more than 270 degrees worth of turns. Now this is something you'll want to have also near your U for ground so that you've got all the electrical connections you need in the same place when the electricians come back to put the panel on the building. So you can see here in the bottom of this interior wall footing, we have a structural wall that lays in the middle here, so we have to have a bearing footing underneath it. We've run the conduit for the home run back to the electrical panel, and in this case it's just on top of the rebar that's going to be set up in the footing. Now we'll actually pull this rebar up when we pour, get it up off the ground, so there's enough flexibility in this pipe to allow us to do that. And then run this again, keeping it towards the bottom. We don't want to have the pipe up in the air in here without support underneath it, because then when we pour the concrete it'll have a tendency to just snap this under the weight of the concrete. So we got it down where it's supported underneath. Run it along here, again keeping it close to the wall, and we get up into the bottom of the slab area. We've just dug out enough to basically keep the top of the pipe flush with the bed that's going to be our base for the insulation and for the base of the concrete. Now we've run this all the way out, and we've taken it to our first stop over here, which is a switch that's actually a three-way electrical switch, which means we have a light switch here that powers a light in the house, and then there's a light switch on the other end of the building that also powers the same switch, so you can turn it on and turn it off from either side of the room. So we've got conduits running back over there to carry power back and forth between the two, and then a third line which runs out to power another switch on the other side, so we basically can tie the main line into that second line and create a secondary source at the other end of the building. In this building, the clients had requested floor plugs in the concrete slab. So we've gone ahead and laid our conduit and our 3 plug locations out on the floor and set up our boxes. The key with these boxes is to have them above the level of the slab. You do not want to finish them flush with the slab. If you finish them flush, it's going to be difficult to get all of the equipment in there and get it set up the way that you want it when it's all said and done. So the electricians would actually prefer you leave it high. They can then come back with a Sawzall and cut it flush with the concrete. It's a little bit backwards than what might be intuitive, but that's the way that the electricians ask for it to happen. So basically set them. You can put little pieces of rebar down into the grade that'll hold them at the right elevation and in place. And as you're doing your pour, you just want to make sure that they stay above the finished level of the concrete. Now we've stubbed out the main sewage line outside the building here, just about a foot, maybe 16 inches outside, and capped it. So we don't have to worry about this right now. We'll dig the trench. It's going to connect to the rest of the sewage line once we've completed the pour. We've also got a water line coming in that we've insulated as it goes underneath and into the slab, and the same thing, cap that off, and we'll deal with that once we're done with the slab itself. And you can see in this end of the building, we have a very deep footer. We had a lot of fill that we didn't quite trust the structural strength of the fill, so we dug down through it until we got to natural grade. This is a pre-existing fill. Now, so what we've done is we've had to use a large form board on the bottom and then continued up with another 2x6 on top to get the height that we needed to be able to fill all of this in with concrete without it flowing out from underneath. So if you have an area where you can't get just one single board that's going to span the distance of your form, it is okay to put 2 on top of each other. You may end up with a slight line there when you pull the forms off where those 2 boards come together. Most likely that won't be a problem because it's going to be basically at grade anyway when this is all backfilled. Again, you can see we've got the insulation on the water lines as it passes through the concrete in the right of the frame here, and then the sewage lines are wrapped in a felt and taped. And again, here you can see this is a vent pipe coming out of the concrete. We have it wrapped in this felt and taped and then wired off to a block holding it in position so it doesn't move during the pour. Same thing if you want to hold something off the ground. Here's a sewage line we needed to hold up off the ground. We've got some rebar with a wire harness just sitting across
to keep it in place. The toilet flange you want to have just above the grade of the concrete. Again, you'll be able to cut that out flush once the concrete has been poured and do the finished concrete at that time. So once all your sewage lines and water lines are in place, you can backfill around them, and then you're ready to create your grid and pour your concrete. Radiant floor heating is one of the most efficient and comfortable sources of heat for any home. It's a very simple process to lay out radiant tubing once you have an idea of how many zones you want to have and that you've sized the system properly. So if you don't know how to do that, you might want to contact your plumber and see if they would, for a fee, size a system for you to make sure that you're going to have a water heater or heat source that's going to be strong enough and efficient enough to heat your home. And once you've done that, the basic premise is to take the radiant tubing and lay it out in the field and attach it to the grid of the rebar. Now, if you don't use rebar, if you use a welded wire mesh or some other kind of reinforcement, there are other ways that you can set the tubes in place. They actually make little stands that you can put right onto the insulation or onto the slab, the sub-slab surface that will hold the tubing in place as well. If you're using rebar, that's pretty much the easiest way to do it, and you can just attach it right to the rebar itself. Now, it's important to know where your walls are going to be when you're laying out your tubing. You don't want to have radiant tubing directly underneath the wall. The risk of that is that you might actually shoot a nail when attaching the wall to the concrete down into the radiant tubing. So we use paint to delineate where our walls will be so we can run our tubes and know where to stop them. Like you can see here, we've turned our curve before we get to that green so that we know when we shoot our wall down we won't hit that pipe and damage the tubing in any way. To keep the tubes in place, we use just regular zip ties. And now we want to be sure when possible to keep the tubing underneath the rebar or running to the side of the rebar. Now here we're crossing perpendicular, so there's not much choice here. We have to go on top. But the lower you can keep it on the rebar, the better, so that you have enough room between the top of the tubing and the top of the slab. The reason this is important is if you come back later and do some saw cutting, or like we said, if you have walls that you're nailing down, and let's say someone comes back at a later date and wants to remodel, and they shoot down with nails their new walls into the slab, the more concrete you have between the top of the slab and the top of your piping, the less chance there will be of damaging these tubes in the future. That's a very important detail to keep track of. Now, in general, we try to avoid putting any joints of the tubing in the slab. The technology has advanced such now that it doesn't really matter, and the joints are very, very reliable. Nonetheless, if we do have a joint in the slab, what we'll do is we'll wrap it with pipe insulation and tape it all the way around so that there's no likelihood for that joint to expand and contract should the floors get cold and then warm back up and cold and warm back up. Because the actual fittings themselves are made out of metal, we want to keep them as insulated as possible from any fluctuations in temperature in the slab. Now, this is important also if you ever do damage a water line, you can go back into the slab and chisel it out and use these fittings to replace damaged water lines. And again, I would suggest that you, when you do have the replacements in there, that you insulate them and isolate the new metal fittings from the concrete slab itself. And you can see here, this is basically what the field will look like when you're ready to pour. You can see again on the left side of the photo here, the tubing turning back towards the right before it gets to that green line, which indicates the exterior wall. We have a wide exterior straw bale wall here, so we're staying away from that with the radiant tubing. Well, the final thing to do before you actually pour your concrete is to test the tubes to make sure there's no leaks anywhere or pinholes in the line. Basically, you want to set about 80 or 90 pounds of air into these lines and let them sit overnight. Come back the next day, look at the gauge, make sure that there's no decrease in pressure. If there's no decrease in pressure, you're all set, you can get going. If there is a decrease in pressure, then you have to do some troubleshooting to find out where that is. I would always start at the fittings right here where we've set up our control gauge, and then if you do have any joints in the slab, those would be the next place to investigate. After that, you're just going to have to run up and down the tubing with some soapy water to try to find any leaks in the lines. It's very unusual for this tubing to have leaks in it, so if there is any kind of loss of pressure, it's most likely going to be at the fittings, and you'll just need to do a better job of crimping them together. Concrete slabs have a tendency to crack, and there's not much you can do about stopping that. We use the welded wire mesh in there to stop those cracks from opening deeper once they've occurred. You can also use fiber down in the concrete when you pour it, which will help stop those cracks from starting initially. But basically, you're going to get cracks one way or another. So one way to avoid getting cracks where you don't want them is to put control joints in the concrete. You can do this when the concrete is wet using what's called a grooving tool or a groover. And basically you want to run the groover on the end of a pole like we use for our bull float and run it across the concrete about 8 to 12 feet apart. Now if you're doing smaller slabs like sidewalks, then you want to kind of try to keep it in squares. So if you've got a 3-foot sidewalk, then 3 feet on center you want to put your grooves. Another way to do it is to use a masonry blade on a circular saw after the concrete is cured, and you can saw cut those grooves. Now the idea is to keep it about 1/4 inch of the depth of the slab. So if you've got a 4-inch slab, the depth of your groove should be 1 inch. You don't want to go over that because then you get into the structural integrity of the slab itself. So to do a groove, it actually takes quite a bit of skill. You're pushing wet concrete out of the way with the grooving tool, especially if you have a long run to go on. It can be a pretty difficult task to do. Now you can see there's a slight line ahead of where we're pushing our grooving tool right now, and we'll use more and more extension handles as we get out there further into the field. The line that we're following is just simply a snap chalk line that we do ahead of time, which we'll show you a little bit further into the project here, how you can do that. Now you see we kind of work it back and forth. We're not just able to push straight through all the way because it's quite hard to push through the concrete. We've let it set up enough already that it's starting to firm up. If we get in there when it's too wet, it'll just squish all over the place and it won't hold the shape of that groover. So now that we're all the way out with the full extension of our poles, all the way out to where we need to be, you can see the bounce in the pole. You want to be careful not to bounce it too much because that'll start to wobble at the actual base of the groover and will actually start to draw moisture up to the surface from the bouncing of that on the surface. So as steady as you can keep it, you need to be able to get it to as far out as you want. And then here the difficult part is lifting it high enough so that the back end comes off of the concrete before you start to draw it towards you. If you don't lift the back end off the concrete as you draw towards yourself, it'll actually rip the concrete out and make a total mess of the concrete. And regardless of how good a job you do pulling or pushing the groover, you're going to end up with lines outside of the groove that you wanted. Those represent the outside of the plate that you were just pushing to make your groove. So you need to come back with a trowel and clean those up. And we're using a trowel here on an extension pole, which takes quite a bit of skill to do. You want to set it down and then give it just a little bit of a twist so that it lifts the front end of the trowel up as you're sliding it across. And by using the steel trowel out on the extension pole, you can clean off those lines and get a nice clean groove right down the middle without any representation of where the outside of the plate was. So here we're snapping lines. We're going to run some perpendicular grooves to our main groove. So we've got them marked out on the side of the foam board exactly where we want to have these grooves in place. And in general, you want to keep them about 6 inches away from any wall that they're going to be running parallel with. Anytime you have a groove that's right on a wall, if that wall is framed slightly out of square, you're going to see it. It's going to be very obvious. Whereas if that groove is either buried in the wall or out 6 inches from the wall, you won't be able to see the variations in the framing at all. So here we just take a basic chalk line, put it on our marks, pull it tight, and snap a line, and then we can use our grooving tool right along those lines. So now we go along the lines that we've snapped out, again using the same grooving tool, and you can see the force it takes to move this plate along. Again, we want to bounce it enough to get movement to it, but not so much that we start to bring moisture to the surface. And we'll work it back and forth across from one side to the other. And you can see right there in the center where we meet that perpendicular line that it actually creates a little bit of a blob of concrete in that line. That's pretty much impossible to get rid of. What we want to do is push all the way through here, and we'll move most of it out, but it will push a little bit of concrete into the perpendicular line. So one way we can do this is wait for things to firm up just a little bit so we can get on there onto the concrete with our knee boards. And once we're on there with our knee boards, we can use a hand groover to get in there and clean that up so you don't have any misplaced concrete. We wanted to slow down the curing of the surface of the concrete so we can continue to work it with the trowel, and then also later we're going to be doing some stamping. So we're using what's called con film. We just spray that on top and trowel it in, and it slows down the whole process, and it leaves the surface much more pliable for a longer period of time. So if you're going to be doing any significant troweling or stamping, then this is a really important way to slow down the cure. Now here we're just going to go back and forth over these grooves. You want to keep working this stuff as the concrete's curing. Again, we've sprayed the con film on there, so we've slowed down the cure process, which gives us more time to work these grooves really clean. You can see as he lifts it out, as he lifts the grooving tool out of the groove, he doesn't just pick it up. He'll actually put it in at an angle, push it, tilt it, pull it back at an angle. So watch here, the tilt goes up and tilts it back, and then as he comes out, he can either pull it out at that angle like that or tilt it back up the other direction and pull it out. If you just try to lift it out of the groove or pull it straight out the back to the forms, again, you'll get a mess of concrete all around the area where you did your lift out. Now the whole time we're doing the grooving and the cleaning of the grooves, we want to make sure you got someone behind you with a trowel who's cleaning up the lines from the edge of the grooving plate and working that con film back into the surface. The final pull on the long groove we've got here, now we're trying to clean this last groove out. It's the last pull we'll do all the way through. You have to have a second person there to help you get the grooving plate off of the surface of the concrete, because with this much extension pull, there's no way you'll be able to lift it and maintain that angle. So you see as we get right to the edge here with the grooving plate, the second guy will lift it off at the end. Another type of joint is called an isolation joint. Now these are used to isolate two different slabs from each other, or a slab from a footing. The idea is that if you don't do that, they're going to stick on each other as they try to move, and because they're set up as independent pours, they'll want to move at different times and in different directions, and so with them attached to each other, they'll end up cracking. So if you have a footing and you're going to pour, say, a floating slab on top of that, what you'd want to do is put some type of plastic or other type of isolation material in between the footing and the concrete slab. That'll allow each slab to move independent of each other. If you have drainage issues on your site, it's a good idea to install a curtain drain. Now basically what that is it's a perforated pipe that's laid around the perimeter of the foundation. You can cut that down slightly below the grade of the footing, off to the side, or have it even with the side of the footing. Now you want to then pack gravel, loose gravel around that pipe, and wrap the whole thing in an earth fabric, which keeps the dirt and soils from getting into the drain. And also, especially if you're doing a wall that needs to be waterproofed on the interior, you want to use what's called a sheet drain, which is a plastic board that allows water to move through, but then it has fabric on one side of that, which again keeps the silts out of that from clogging it up. So that's one way you can collect the water around the outside of a house, pipe it together, and then daylight it out somewhere downhill so that any water that gets into the area around the house is immediately drained away. Otherwise you have moisture problems coming into the house, and what that creates for the inside as well can be a problem. Concrete can be a hard and somewhat unattractive surface if you just leave it to its own devices. Stamping is one way to bring a little more depth and character to concrete. Now when we do stamped concrete, we typically add one color to the concrete that we're mixing and placing, and then a second color is broadcast along the top and then stamped down. It's a color and it's also a release agent, which allows us to pull our stamps back off of the concrete without pulling the concrete away from the slab surface. So you can see you get a deep mottled color, and this one, for example, is designed to look like a slate or some type of stone. And you can really play with the colors and textures with different stamp patterns to get different designs. It adds something of character to a house rather than just having a finished troweled surface. It's one way to put a little more character into your floor. And these are rubber stamps that we're going to use for the actual stamping process of the concrete. Now they've got different sizes and different textures on each one, as you can see. There's a small one here and then a larger one underneath it. And they have different patterns on each, so that when you're using one against the other, you don't have a continuing pattern that's obvious in the finished work. So here you can see we're broadcasting the color on top of the concrete. Now this is the second color we're using. As I said earlier, we have one color already in the concrete mix. So you see, you just kind of toss it out. We're using a heavy brush and just slide it out across the surface. Now the areas that you're not stamping and that don't have the secondary color on it, you want to continually work with a trowel. You recall earlier we talked about putting down con film to slow down the curing process. We've got one guy working a trowel continually to keep that surface malleable so that the stamps will actually work. So when you go to lay your stamps down, it's important that you don't slide them into position because that will show up in the actual concrete surface. So here we'll lay one end down where we want it, roll it down into place, and once it's in place, then we can use a tamper to tamp that pattern that I showed you earlier on the stamps themselves. Use a concrete tamper to, or excuse me, just a regular tamper to imprint the surface of the concrete. One thing that's really important with the tamper is that you hit straight down. If you hit the stamp with the tamper at an angle, you'll rip right through the stamp and ruin the stamp. And these are not cheap. They're fairly expensive. So if you're going to be doing this work yourself, you want to be able to take good care of your stamps. So work your way all the way around. You can start on the outsides and work your way into the middle, however you want to do it, so that you remember that so you can be sure that you've hit every spot with the tamper. You don't want to miss a certain spot and then have that show up later once you come back to finish the floor. Now we'll come and bring the second stamp. We're going to use 2 large stamps for the majority of this building to cover more ground quickly. You see we lay it down over the top so that the new sheet laps over the old sheet, and then we'll reverse that. We'll put the new sheet underneath and continue with the stamping. So what this does is it creates a seamless edge. So we're going for the look of a natural stone. We don't want to have one stamp end and the next one begin next to it. So this way you get a very seamless transition from one stamp pattern to the next. Again, working our way all the way around with firm and controlled tamping so that we don't blast through the actual stamp itself. Now you can see we only throw out as much of the secondary color release as we can do with the stamps. We don't want to get too far ahead of ourselves. If we lay too much color down, it actually will slow down the process and it'll mess up the curing of the concrete. So we'll just lay it out as we go, enough to move one stamp to the next. And again, slowly peeling it back rather than trying to slide it out of position. You'll notice when we turn, it's going to be hard to tell here on this because we're turning directions, but when you add the next stamp pattern down, you always want to turn it 90 degrees from where it just was so that you don't pick it up and lay it down as in a line, because then that pattern will start to repeat itself and you'll start to recognize it in the finished product. So by taking your second stamp and actually rotating it 90 degrees, you'll get a much better, less predictable finish. And again, don't forget to have someone in the background working the concrete to keep that con film. You can see areas where it was drying right there where he just slid over. We're keeping that active and keeping the concrete pliable so we can do the stamping process. We've got a long way to go before we get around this whole building. So now we'll continue around the outside of the building first. It's important to have a game plan so you don't end up getting stuck somewhere and not being able to get off the building. So here, again, we'll work around the outside first and tamping as we go. Again, just laying enough of the color release ahead of us so that we have something to work on, but not so much that we're putting it out ahead of time where we can't get to it within a reasonable amount of time. And when you go over the grooves that we'd cut earlier, we want to make sure to use our wheel to clean those out so we don't have lots of color sitting in the. If we have too much color sitting down in those grooves, it shows up as a fairly obvious color change in the final product. And you can see here as he turns around, he's not only turning the stamp from one direction to the other, but he also rotated it 90 degrees. Again, laying it down and then going back and stamping over the top of it. And we're moving back down along that same line, going in the opposite direction now. So the idea is to keep moving and to keep shifting the way that you lay the stamps down. Like I say, the turning it of 90 degrees, that basically gives you a random pattern out in the field. If you use it the same way, it's going to be very obvious in the finished product. So that's really important to remember, to keep rotating the stamps 90 degrees as you shift them from one position to the next. So I'm aware that this is repetitive, but I'm going to show you again to turn it 90 degrees as you change directions and add your next stamp. It's possibly the most important thing about creating a natural looking pattern. And then again to put the new stamp underneath the old stamp. And go back and clean out your lines so you don't end up with strong colors down in all the grooves. For areas where the large stamp won't fit, we have the smaller secondary stamp that I showed you earlier on. Now again, you don't have to use the tamper. We're just going with a magnesium trowel and hitting it hard enough to imprint that pattern onto the concrete. This is a great thing to have for areas like this where you just can't get that large one in there. You can get the smaller one in, and it's a random enough pattern that you won't notice any difference when you take it off. With the techniques we've shown you in this production, you should feel confident building a small slab or even a large slab under a full-size house. There's even some tips in here about how to do stamping concrete, which you may or may not choose to do, but it's nice to know how to do anyway. Now keep in mind that there's a lot of ways of doing anything when it comes to construction, so you may have learned some different techniques over the years, and that's fine. Try to use what you know and mesh it with what we've taught you here, and you'll come out with a great product in the end. Now with any type of construction, there's going to be a learning curve involved in this, so just be patient with yourself, and above all, have fun. Thanks for watching. Environmentally stuff and other good things too. Number of opportunities to do something with, I don't know why opportunities came out of my mouth. Hi, how are you? Nice to see you. Welcome to the program. Big slabs and concrete foundation work. I can't figure this out. For solar, passive solar radiation.